Hey guys, welcome to the channel. So today we're going to talk about my Mini Spark Gap. This is actually the smallest, sorry about that, rotary spark gap I have ever seen, actually. And yeah, the disc is actually all metal. And it took me 2 days to get this thing designed, implemented, and actually built, due to the complications of actually trying to set these electrodes. So it's just like any other spark gap. It doesn't have any type of synchronous operation yet. I will be implementing that more than likely using a VFD that is controlled off of the mains frequency that will use optocouplers, and I'll somehow figure that out, because this is DC, as you can tell. It's run off of a USB power bank, and this light and everything that will be explained shortly. So I was going to use like bakelite for the electrodes, for the thing that I want to focus, for the actual disc, and have it to where the electrodes were both on one side, where it would clamp it like that, you know, where, like what you would normally see, like this, and they would arc right there. But the bakelite, I was afraid it would get hot. Bakelite's kind of heavy and thick, and I didn't have any way to mount it to the shaft here. If it'll focus on. Because if you pay attention real closely, you'll see that this is not a regular flat shaft on one side. It's actually a triangular shafted motor. And what that means is there you can see it. So it wasn't really easy to get it to work. So I instead went with a metal disc that was already terminated with the proper shaft, and many of you will automatically recognize this. This is actually erector set components, and I made sure and use the nylon washered nuts, because otherwise the vibration and RPM, the centripetal force, will cause the nuts to loosen, and that was very, very bad, and it completely undid everything I did. And I also had to do that for the spark gap contacts here. Now this thing took me about 2 days to actually build. 2 days and about 6 hours. It was very difficult to figure out how to build, because I wanted it all out of metal. Because I'm going to be running this with a ZVS Tesla coil, spark gap Tesla coil, you know. And those things, they generate quite a bit of power, and so the heat will be quite high. Now this, since you have these knobs here, they move a lot of air, and I mean they move quite a bit of air. So it will help to cool it, but the metal means you don't have to worry about it getting hot. I will be having a filter coming into the power to prevent the high voltage spikes, that since the voltage is actually present onto the shaft, from when it arcs, it has to go through here, through the disc, which is on the metal shaft, and to the other electrode. Well, that means that the rotor has a high voltage potential on it, reference to ground, because this is going to be installed, well, by metal structure, but it'll also be connected electrically, so obviously there will be a way for that high voltage to potentially escape. So I will be using an isolated power supply to run this as well, but I don't want to mess with the PWM because it's wirelessly controlled, and I'll go over that in just a minute. So to all you spark gap people out there, this is probably pretty simple. But this is the smallest one I have ever built. I haven't ever built a rotary gap this small, especially for this type of RPM and for this type of power. The only plastic on here is obviously the case of the motor, but these, which I will be swapping these out, which are from the erector set, for ceramic, so that I don't have to worry about heat at all. I don't have to worry about it getting hot, don't have to worry about anything like that. So those serve as the standoffs to hold these electrodes up at the proper altitude or proper height, along with these jam nuts, which also serve as another washer, but it also makes sure that this screw can't loosen. So as you can tell, I put the nylon washers on here, the rubber rings inside there. And if you're going to build it like this, you have to have a dual screw access point installed. You have to have it secured with 2 screws. Otherwise, if there was just one, it could pivot, and I was having huge problems. Now, everything of this is adjustable. If you look closely enough, you should see a little gap in there, right here. And that's because if you loosen that, you can this nut, you can actually slide that entire thing back and forth. You just don't want it too close to this. That's why maybe swapping these to nylon, which would be an even better idea. Nylon can deal with the heat, but they're not going to be getting hot. But that means it won't have a reference to ground. However, this actually works as a safety gap, so that's why I really, really prefer to be there. So, you've already recognized this. This entire mechanism here is adjustable as well. So this will get your course adjustment. It will actually make it to where when it comes in contact, it's farther out or back. And this allows you to adjust it that much. So you can have a very high voltage power supply driving this, as long as you don't allow it to get too close to ground, or simply isolate it from ground, which I may end up doing that, but that means it could still jump through to itself, which again would serve as a safety gap. So we're not even going to talk about this side because it's a 100% mirror of this side. It's just on the other side. So if you loosen this jam nut, it actually, you can slide this in and out because it's threaded. This serves as the actual electrode. And again, use something like lock washers or something or like this to make sure they don't move. So that's the mechanical standpoint, and I may actually build another one of these. I'm not going to disassemble this one because it's such a pain in the neck to get it actually centered and fixed again. So now we're going to talk about the driver. I was just going to hook it up to 5 volts directly, but I really didn't like that idea. I wanted to be able to adjust the speed of the spark gap, but I didn't want to have to, be standing right by the coil and adjust the potentiometer. So that's when I thought, hey, I'll go to Walmart, where I had already gone, and I got one of these. It's about $5 for these strip lights. Okay, so this uses a PWM to actually control the speed of that light. I'm at my grandmother's house, that's why there's all this stuff. So what that means in essence is when you adjust the brightness of that light, this actually has a 3-channel PWM that is capable of driving up to 2 amps per channel. My other one can drive up to 4 amps per channel, but this thing only draws about 860 milliamps. No, wait, it was 80 milliamps, sorry. So it's very, very low current. It's less than the LEDs. Now, it is an inductive load, so you must have a freewheeling diode across your motor input in reverse bias, So if you're building a Tesla coil, then you probably already know about PWMs. And if you don't, the reason you have to have that is because, in fact, I can show you what I mean. So I'll just flip this over real quick. And I'll just hook this up where the lights are actually forward bias this time. So they're on. That's the motor. Okay, so they're running right now. But I have it in the green channel, but look at how the green is still on. That is because the motor continues to push current through the LEDs because it's a brushed DC motor, so it acts as a generator. So I just flip it backwards as to where I know for a fact that it will actually be in reverse bias so that it will absorb the back EMF while it's on, because this is a PWM. Now, the reason that this is so important is because of this reason right here. So, this is running off of 5 VDC, and now, oops, forgot about that. You have to hold it while it starts up. Stop it again. I want to let you guys see it spooling up. Okay. So spooling up in 3, 2, 1. And it produces quite a bit of air. So that's good for arc quenching. And use the included remote. And you'll see those lights turn on because now it's not at 100% duty cycle. See it changing? Or hear it? You'll also hear the whine. And now you have a completely wirelessly controlled rotary spark gap. How cool is that? This is also something else that's pretty cool. Okay, so let's say you have set up your spark gap at the proper RPM, right? So let's say that this is it. Also, I made it to where I can have it at full power now. Before, I couldn't turn it up all the way. It would start hitting. So I set it properly. So now you can crank this all the way up to 100% duty cycle. Oops. Or just hook it up directly to the 5-volt USB and it won't hit. So that's good news. So let's say you have a power fault or you unplug the sales coil, you're done using it for a couple days, and we're going to simulate that. So we're going to let it completely spool down. Okay. Also, that diode across there will actually make it slow down quicker because of what's called regenerative braking. So now we're going to reconnect power. We're just using a power bank here. And look at that. It'll automatically go back to what it did. Some of the LED strip lights will not do this. Some of them go into like the flash setting or whatever, or just won't remember. This is absolutely phenomenal because it remembers what you did. Now you can still use the flash function, and if you put in that, if you use the like flash with the diode properly, you can actually make it to where your Tesla coil will, and here I'll show you. Hear that? But first, apparently you have to have it at a higher RPM. See, look, it even knows that it was in flash. So we're going to spool it up so I'll have a high enough speed. So we're at 100% duty cycle, which is just the MOSFETs are completely on inside that driver. So 5 volts is just getting to it. So now we're going to go to flash. And as you can tell, the lights are dimmer. You can also go there. See? I know you can hear that. And it's in the green channel. I have the motor in the green channel. Then we'll go to fade. And this is a PWM, so this will be just fine. I have run this thing at full tilt for up to 20 minutes at a time, and it doesn't even get hot. The motor doesn't get hot at all. The controller doesn't get hot. I mean, it's still room temperature. Temperature hasn't increased at all. But yeah, you can just turn it. You can just use the green if you want. And I just turn it all the way up and just leave it. It doesn't hit. There you can start seeing the banding a little bit, not much. And if you change the frequency, you just decrease your power. See if I can figure out what the rate of this camera is right off of this. Probably not, because it doesn't use, I'm not sure what the RPM of this is. I don't have a tachometer yet. I'll have it on here. And it's going to be the type where instead of it actually being on here, it's just going to be one of those Hall effect clamp type or something, where it'll just detect the nut or something, because otherwise you have more weight on here which will imbalance it and you'll have problems. So that is my miniature rotary spark gap. And it produces a lot of breeze. But I feel absolutely confident running this with a high current power supply. I wouldn't use a mop because those things, they get really, really hot. The arcs are just, the sparks are really, really hot. However, now that I got this working at the proper RPM, there's so much air movement that I feel that it'll be okay. I mean, look at that. It's moving that. That's not a good representation. Okay. But since it's all steel here, it's all metal. No plastic, no bakelite, none of that stuff. Of course, bakelite, I've seen it used and things like that. But there you go. Thank you for watching my video. Like, comment, and if you've seen a spark gap smaller than this, please tell me. Show me pictures of it. Make a video of it. Put a link to it if it's on the internet, and I'll definitely take a look at it. And if you guys have any ideas on for me to improve this technology or this technique, please do. But I haven't found any DC miniature spark gaps that you can buy ever. I haven't found any. That's runnable off of a USB power supply. That's wirelessly controlled. So thank you very much, guys. Oh, also one other thing that you can do is, let's say that you have it in the green setting, right? So right now I just pushed the blue button, so we're going to put it back into green. Sorry about that, I just turned it off and didn't realize it. I was trying to figure that out. So you have it in green. I'd recommend not having it in white. Click the green or the blue or the red, whichever channel you put the motor on. So you have it on green, right? Now you have two other channels. So what you can do now is, if you use a comparator on the output of this and an LC network or a resistor, a DAC basically, you can use like a solid state relay or just a relay or whatever and connect when you turn this off and you turn it back on. Only the green, only the red, or only the blue will turn on. And I'll just prove that to you right now. Alright, here we go. So we're going to turn it off. Okay. Alright, so it's off right now. Let's even unplug it, so it's unplugged, no power. There isn't any really capacitors in here that store a lot of charge, so there you go. So it stays off. So, alright, you have your Tesla coil, let's turn it on. So now you can have your spark gap spooling up, and then you can click the red, or the white actually, and now all of your channels will enable. And what that means is you can actually have your motor turn on first, and then, boom, you can turn your power supply on, your high voltage power supply. So you can actually have your Tesla coil turn on completely wirelessly. Even if you have a fault, you can program it to where the green always comes on. So I would recommend, before shutting it off, switch it back to your green, or your red, or your blue, whichever one you have it set on, your motor. That way, your spark gap always turns on before the power supply turns on. That way, one remote can turn it all on. Now, the problem with just trying to use like a MOSFET and a relay to turn your transformer on, or with ZVS or whatever it is this. Is now it will dim the entire string, which means that, yeah, your relay switch will be turned off. So that's why you need a comparator with a dropout voltage that is below there. You just have to know what your voltage is coming out of there and make sure that when you dim it completely, your power supply doesn't shut off, which is easy. I've done that before too. So, and watch this. So let's turn it all the way back down. Turn it off. Unplug it. Plug it back in. Boom. And it's still dim. How cool is that? $5. So there's a small review of the LED light strips. So, 2-in-1 deal. So, I know the video was really long. I'm sorry for that. The actual colors of this strip are actually really nice. And it's quite long as well. You get a little reel. They're not as high quality as a Monster one, but if you're just buying it to use as a motor controller, you don't care about the quality of the strip. Just please use a freewheel diode across your motor, Now this is not how it's going to be wired up, where it's just spun around the pins. Now it's going to be soldered and all that, you know what I mean. But thank you. See you later.